I am Dharmendra Pathak. In my previous videos, I will describe about light, optical instrument, lens like a convex lens, concave lens, its terminology and rules to draw ray diagram. Today in this video, we mainly discuss about how to draw a ray diagram with help of convex lens when object is at various distance from the lens and the image obtained by convex lens. We describe about its nature, how we describe the image formed by convex lens. And here today we mainly discuss about different conditions in which convex lens form different types of image. And here first we write a ray diagram formed by convex lens, and we consider object is at various distance from convex lens, and then with help of rules we draw ray diagram and describe nature of image formed. At first we describe about when object is at infinity. Infinity means distance of object can't be measured, unknown or infinitely distant. On that condition, at first we draw convex lens with help of compass. And suppose we consider here it is our convex lens, and then we draw optical center or central part of lens, and then we extend a straight light or a straight line, listen, which is known as principal axis on either side of lens. After that, on a copy we measure 2 centimeter distance from optical center, like a 2 meter right from optical center, and we measure that here, that distance is called f. Here it is called f. It lies on principal axis and we mark it by f. Again we measure 2 centimeter more distance, twice of that principal of focus, and it is called twice of principal of focus 2f. On either side we measure same distance, and here also same distance in left, and it is called f. Similarly, more 2 centimeter we measure 4 centimeter, which is known as 2f. And here when object is at infinity, it means what? Only parallel beam of light reach up to lens, and therefore to draw image only we draw parallel image or parallel ray of light coming from object up to axis of mirror, up to half of a mirror. And here we consider a ray of light coming from object or beam of light coming from object, And according to rule, we know that the ray of light parallel to principal axis pass through F, and that ray of light pass through the F. And here carefully we join that ray of light through F. And here also by same way we pass that ray of light through F. It means what? The parallel ray of light pass through F. Parallel ray of light pass through F. And both rays meet at F. That is called image of object. And then we describe about nature of image. We already discussed that convex lens generally form real image, and real image found in inverted state. And how we know it is image? The object is towards left side of that lens at infinite distance. Then its image is formed in right side of lens, and therefore the first nature of image will be real. Other next, real image always found inverted. That is, when object is upright, then image will be downward, and when object is downward, then image will be upward. That is in opposite side of that of principal axis, and real image is always inverted. We don't know where object is here, but we know that the image is formed at F. The third nature of image here we describe about where image is formed at F. And here object is at infinity. It may be larger. Why? Because then only it is visible. And image of object is too small. That is coincide on F. And here other is related to which type of image is formed. The image will be highly diminished. As for example, sun is at infinite distance from the earth. In our eye, convex lens is found, and its highly diminished object causes it seems like a spherical football shape. And why? Because diminished image is formed there. And such type of nature is obtained, like when object is at infinity, then real image obtained, inverted, and image is formed at F, and image will be too small, infinitely small, too smaller, therefore it is called highly diminished. And in this way, first condition we draw here when object is at infinity. In the next condition, we brought objects closer to the lens. And here now we consider second condition of image formed by convex lens. In second condition, we consider that object is slightly closer than infinity, but distant than 2f. Object is beyond 2f or behind 2f also we can write. And in this condition also at first we draw convex lens with help of compass. That lens should be erect, straight. If it get inclined, then image will be formed at wrong position. And then we draw axis of that lens. At central part we draw optical center and we mark by O. And then with help of a scale we draw principal axis. Here it is called principal axis. And with help of a scale we measure equal distance from optical center about 2 centimeter, which is called F. And then Towards left also we measure f. On both sides we should measure equal distance from optical center. 2f, twice of that f, which is called 2f. On both sides we measure 2f. And here we mark that point is called principle of focus. Double of principle of focus or center of curvature. Principle of focus. Principle of focus. Listen. And here, according to condition that is object, we consider that here object is erect upward. And according to rule, at first we consider the ray of light pass through the head, which is parallel to principal axis. Listen, here we draw one ray of light parallel to principal axis, and that ray of light pass through f according to rule. Why? Because when the ray of light parallel to principal axis pass through the lens, then it get converges at f, and here we draw f. It pass through f. And in next condition we can take a ray of light which pass through optical center, and we know that the ray of light pass through optical center goes without deflection, that is no bending takes place. And we take another ray of light which pass through f. See here, now it is called f. And here we take a ray of light that cross O and pass through f. It goes without bending, no need to refract it. And we found that these two rays of light meet at that point. It means what? It is the position of image. And here we draw image of object. Listen here. And already it is clear that the image is from just opposite side of lens. And therefore nature will be, first nature is here real. Why? Because object is at left and image is formed at right of lens. Real image found always inverted. Object is towards upward and image is downward of principal axis, therefore it is inverted. And where image is formed between f and 2f. Any place between f and 2f, that depends upon how far it is from 2f. How far it is from 2f. And here we write image will be, or nature of image between f and 2f. Listen. And already it is shown that object is larger and image is smaller in size. That means simply diminished image is formed. And here diminished image is formed. And in this way we draw here second condition, image formed by convex lens when object is beyond 2f. And by same way we draw third condition in which object comes more closer to the lens than beyond 2f. And third condition is here object is at f. In this condition, listen here, object becomes more closer, and again we should draw this same term related to convex lens, and then we describe its nature. At first here we draw convex lens with help of compass. Every time we should use compass, and accurately we draw these all terms related to axis of lens. And then principal axis, it should be straight and then we measure equal distance from optical center on both sides, which is known as principle of focus. Twice of principle of focus called 2f. On both sides principle of focus, twice of principle of focus 2f, like that. If that position gets slightly deviated, change, even 1 millimeter change, then image will be formed at a different place than actual, and therefore while indicating principle of focus, optical center, we should draw clearly with help of scale. And according to condition, object is at 2f, and with help of scale we draw object, straight object, not erect, like that. Object is at 2f. And then by same way, one ray of light parallel to the principal axis up to the axis of lens, and it pass through the f. According to ray rule here, the ray of light parallel to principal axis pass through the f, and second ray of light we take from top of that object and which pass through optical center. It goes without bending. Listen here carefully, we draw without bending. If slightly that position gets changed, then our image gets deviated from actual path. And what we found that image will be exact position at 2f. No any deviation found there. See here. It means what? When object is at 2f, then image is formed at same position in opposite side. And here we describe nature of image. Object is towards left, image is formed in right side of lens. Therefore first is here real. Real image is always inverted. Third is here, image is, object is at 2f and image is formed at same position. And third is here at 2f it is formed. And fourth is when we measure that, when object distance, image distance is same, then height of image and height of object will be equal. That is magnification 1. And here object image will be same like object. Of equal height also we can write. And here third condition is at 2f, then convex lens form image, real image, inverted image at 2f, and height of object and image is equal. And now we consider object comes more closer to the lens, and that is fourth condition. We consider that object comes more closer. Object is between 2f and f. On that condition, at first we draw same as a convex lens with help of compass. We imagine principal axis. We draw axis of lens, optical center, and the ray of light pass through the optical center, a straight line which pass through the principle of focus, center of curvature. It is called principal axis. And then we measure distance from optical center, certain distance about 2 centimeter, which is called f, and 2 centimeter more, which is called 2f. Listen. On either side we measure same distance f and 2f. here it is called F, again 2F here. We mark here F, 2F, F, F, 2F. Listen. And according to condition, object is between F and 2F. We consider this is object. And according to rule, one ray of light pass through the lens, or one parallel ray of light pass through the lens which converges from F. And according to rule here, the ray of light parallel to principal axis pass through the F. Another ray of light pass through the optical center. Here it goes through the optical center. And here more accurately we draw here, that should go without bending. And we found that here meeting point of these two rays is away from the or beyond 2F. Listen, behind 2F image is formed. And here we describe nature of image. And how we can describe it? At first, image is just opposite side of object, then it is called a real image. A real image is always inverted. The second condition we write inverted. Third condition is here, image is formed behind 2F, and here we write behind or beyond 2F, it is called behind 2F. And third, it is clear that object is smaller, image is larger, which is called magnified image is formed. When object come closer to the convex lens, then image get enlarged, which is called magnified. And it is called fourth condition of image formed by convex lens. Now we consider next one more condition, fifth condition. Object come more closer, that is at F. When object is at F, object becomes more closer than these all conditions that we described already. And here we consider, firstly we draw convex lens as usual, and then we draw, imagine optical center which is on axis of lens, and then with help of a scale we draw principal axis, with help of a scale we measure 2 centimeter left from optical center, which is called F. Again 2 centimeter from F, which is called twice of focal length to F. On either side we make same length of F and 2F. F and 2F. Listen, F and 2F. And then we label it by F, 2F, O, F, 2F. And according to condition here, object is at F, therefore we make object here F, at F. And here we draw one ray of light parallel to principal axis, which pass through the principle of focus. And according to rule, this ray of light pass through the principle of focus. It bend through the F. Another ray of light we take which pass through the optical center. And we found that the ray of light, listen here, do not meet each other. Both becomes parallel. And in that condition we found that here everywhere that distance will be equal. And then we try to extend it backward. It may meet behind or not. Then suppose here we draw imaginary line towards back side, and here it is already parallel. Then only here we try to satisfy it may meet behind object, but it is impossible. Here also equal distance is found. It means what? Infinity distance is found there. Infinity can't be measured actually where image is found. And here we describe nature of image. And we found that object is towards left, then image is formed towards right. It is clear that why? Because light goes through the F. And here the image is real. Real image is always inverted. And where image is formed, it is unknown. That is third condition. Infinity can't be measured actual distance of your image. And here we write at infinity image is formed. And fourth is here, how big is the image? So what we found that when object come closer, then image get magnified. And here we found that also magnified image is formed. When object come closer to convex lens, then magnified image is formed. And in this way, fifth condition, when object is at F, then image is formed at infinity. One more consider with that here, object becomes more closer to the lens, or between F and O, or between optical center and principle of focus. And sixth condition of image formed by convex lens, when object is between F and O. Here we consider object is between principle of focus and optical center. By same way, here we draw convex lens, then principal axis, then we label F and 2F like that. Here convex lens. We imagine it is axis, optical center. With help of a scale as previous, we draw principal axis, straight line passing through optical center. Then we measure length from optical center to 2 centimeter right, which is called F. Again 2 centimeter, which is called 2F. By same way in left also F. And we label that here F, 2F, F, 2F, and here F, 2F, F, 2F. And according to condition here, object is between F and O. Here we take a small object and one ray of light parallel to principal axis. Listen, here we consider ray of light parallel to principal axis. Listen, and according to rule, this ray of light pass through the F, and here we extend it through F. Listen, F. Another ray of light pass through the optical center. Another ray of light pass through optical center, and here we found that the ray of light going diverging, there is no chance to meet. Listen here, on that condition, but diverging means what? It meets behind of lens, and therefore we extend it backward. It may meet behind object. And suppose we consider the ray of light appears to coming from back. We extend it back side. Another ray of light also in same path it get extended. Listen. And we found that, listen, it meet here. Here it get meet. And that position is virtual position. Why? Because when object and image both are in same side. And how we describe nature of that image as in which direction image is formed? In same direction where object is found. Therefore the image is virtual, which can't be taken on screen. Other head of object is also upward and head of image is also upward. Such condition is called erect or straight. Third condition is here where it is formed, the behind object, and here we write behind object image is formed. It may be behind f, behind 2f, that depends upon size of object. And fourth condition is here. In that condition, virtual image is larger than object, and it is called highly magnified image is formed. Highly magnified. Such condition found in microscope. Simple microscope, microscopic organism kept on stage. That stage position of stage is between F and O, and due to that reason its magnified image is formed behind the object, which is magnified, highly magnified, larger than object. And in this way, here we describe about different or image formed by convex lens when object is at various place. In the next video we discuss about image formed by concave lens when object is at various distance from the optical center, then about power of lens, magnification of lens, like that. Thank you.